So this is basically mercury cell that we call it Hg cell, and also the voltage in the previous one, backline K is 1.5 volt, and here the voltage is approximately 1.35 volt, and at anode zinc amalgam, and at cathode HgO mercury oxide monoxide plus carbon. Also the electrolyte in the previous one there was paste of MnCl2 and NH4 positive or NH4Cl. There is a electrolyte that is zinc oxide and potassium hydroxide. So you know that at anode there will be oxidation, so it oxidizes and loses 2 electrons, and at cathode there will be reduction, so these 2 electrons will be gained by this and it will be converted into Hg, and the net cell reaction is this. So this is all about primary cell.
Okay, sir.
Let me know when you are done with this. So there will be a question like which one, what is the product at anode or cathode, and what will be the net cell reaction for mercury cell and all that.
Done, sir.
Very good. Now, then secondary cell comes, secondary cell or secondary batteries. Secondary batteries, that means we can recharge after discharging, we can recharge and again we can use it easily. Wait a minute, let me switch on. Okay. So in the secondary cell, first I'm going to explain what is the function of lead storage, what will be the reaction and net cell reaction, what is the reaction for discharging, and what is the reaction of recharging the battery. So lead storage battery, and I'm going to draw a little representation of this lead storage to see how does it work. So first of all, it is like this, and then wait a minute. Write with me, please. These are all equal, not thicker and thinner. So basically, these blues connected with blues, and then black connected with black, and there is positive and negative charge. Wait a minute, let me make blue here first. This is negative, this is positive. Now, this is cathode, and this is anode. Anode is made up of lead, and cathode is made up of PbO2, basically. Pb, please write it. And in this, there is a solution of 28% H2SO4. Please write this representation. Then there will be again anode and then cathode.
Done, sir.
Very good. After this, which chapter we are going to start? Again, at anode, there will be oxidation, and at anode, you saw that there is lead, and the electrolyte is H2SO4. That means SO4 minus 2. So these both will combine and form PbSO4. PbSO4 plus 2 electron. So you can easily see in initial on the reactant side, lead is oxidation is at 0, and here it is plus 2. That means it lost 2 electrons, and 2 electron lost, it is oxidation. And again at cathode, you know that there will be reduction. So reduction, that means gain electron, and where does it gain electron from? So 2 electron lost by lead will be gained by again at cathode. So 2 electron, and you know that at cathode PbO2 was present, PbO2. And can you tell me the SO4 minus 2 also there, and H plus? So for balancing, I'm going to write 4H plus, the whole balanced equation. So can you tell me the oxidation state of lead here? After reaction, it forms 2 PbSO4. It forms 2 PbSO4 plus 2H2.
Sir, is it 2?
No, not 2. PbO2, you can see this is X plus 2 oxygen is there, and each oxygen has oxidation state minus 2 will be equal to 0. So X will be equal to plus 4. Yes or no?
Yes.
So this is it. Wait a minute. Let me write the equation again. 4H plus, then it forms PbSO4 plus 2H2. Now again, this is PbSO4. You can see Pb, lead is there, and also PbO2 is there. PbO2 react with 2SO4 minus 2, 2 moles of SO4 minus 2 and 4H plus. So the reaction will be 2 PbSO4 plus 2H. So what I just did, this is at anode and this is at cathode. So after adding this, that means this is net cell reaction. Yes or no? Madhya, the last
Yes, sir.
reaction is cell reaction. So please write it. Then I'm going to write the recharging and discharging, charging or discharging. Uh, how many chapters covered in your school?
Sir, we did electrochemistry half only. We didn't do this part, and the cells we didn't do in school.
Okay, and apart from electrochemistry, solution,
Yeah, we did solutions and then
any other chapter, any other than this solution in electrochemistry?
we did alcohols and phenols. That also we
Direct,
did.
directly alcohols and phenols, haloalkane and haloarenes.
We did that also. Haloalkanes, haloarenes, and then alcohols and phenols. And then we did solutions, and we had done electrochemistry only half, and then after that we got vacations.
Okay, that means you are almost covered. You have almost covered 4 chapters: haloalkane, and then
Yes,
alcohols, then solution, and you are in electrochemistry. So after this chapter, we will
yes,
go for haloalkanes, right?
done so.
Yeah. Now see, you can see this is the net cell reaction that will run. So basically, this reaction is discharging reaction. Discharging reaction. So if in the battery, see, I'm going to write discharging. If in the battery, the reaction goes like PbO2 combined with 2SO4 and 4H plus, that means 2H2SO4. Can I write this? Then it will give 2 PbSO4.
Yes,
So are you getting it? SO4 minus 2 and 4H plus combines to form 2H2SO4. Yes or no? So this is the reaction
yes.
for discharging. And what is the reaction for charging? It's opposite. So when we do charge, the reaction runs like this. Please write. Let me know when you are done with this.
Done, sir.
Very good. Now see, we have the next secondary cell, nickel cadmium cell. Nickel cadmium cell. So its voltage is basically 1.2 to 1.4 volt. So in this, at anode, or directly, I'm going to write anode. Anode is of cadmium, cathode is of NiOH, nickel oxide hydroxide, and electrolyte is NaOH. Electrolyte is NaOH. Now we will see what is the reaction at cathode, at anode. So we already know that at anode there will be oxidation. So how does oxidation takes place? So cadmium react with this basic electrolyte 2OH, and it loses 2 electrons and forms CdOH whole twice plus 2 electrons. Can you tell me the oxidation state of cadmium here and here? Any answer?
So for the first one, it is 2.
Left or right?
Left.
That means this reactant side.
Yeah, the reactant side.
Okay. And what on the right hand side? Cadmium
Is
on the
it
left
4?
hand side. No. Listen to me. Cadmium on the left hand side. Is it in elemental form or compound form or molecular form? It is alone. It is metal. Isn't it in metallic form or elemental form?
Yes, it is in elemental form.
So whenever there is any metal which is in elemental form, what will be its oxidation state? In the previous class, I have told you. In elemental form or in molecular form, the oxidation state will be 0, if you remember it, Madhya.
It will be 0. Yes.
Yes. And when you are talking about this 4, how it can be? OH, you know that one hydroxide ion has -1 charge. So 2 hydroxide ion will have -2 charge. And we need to calculate the oxidation state of X. Plus, you know that OH is 2 here and 1 has -1 charge. So what will be the oxidation state of OH? That is +2, yes or no? What will be the oxidation state of cadmium?
Yes.
So it will be +2. Very good. So you can see it goes from 0 to +2. That means oxidation takes place. And at cathode, there will be a reduction. That means addition of electron. So at cathode, nickel NiOH, OH, that means hydroxide. We are going to take 2 moles and it will gain electron. In the presence of water, it will gain 2 electron lost at anode, and it will form 2 NiOH whole twice plus 2 OH minus. So one more question here arises is that can you tell me the oxidation state here of nickel and here too of nickel? Yes, Nadia, you are not audible. Can you rejoin? What is the oxidation state of reactant nickel and oxidation state of product nickel? Please let me know when you are done with this. Nadia, are you there?
So done.
Okay, so can you answer me the oxidation state of nickel here? Yes or no? Are you saying anything? You are not audible. What is the oxidation state of nickel at reactant side, and what is the oxidation state of product or nickel on product side? Okay, okay, no problem. Please resume. Nadia, are you there?
Yes, sir.
Okay, can you tell me the oxidation gaseous state of nickel on the left hand side, reactant side.
Sir, is it +1?
Yes, it is +1. Very good. And you can see it is +2 here.
+2 on
So
the product
it,
side.
very good. So it reduces. So this is the reaction at cathode and at anode. Again, if I'm going to write the reaction for discharging, so what it will be? So whatever the net cell reaction, that means at anode and at cathode. Oh, wait a minute. I also wrote here anode. This is cathode. So you are going to add these equations and you will get the final reaction, net cell reaction. And net cell reaction is basically charging, and opposite of that, reverse of that reaction will be discharging. For opposite is charging and net cell reaction is discharging. So discharging reaction is basically 2 NiO OH plus 2H2O will give CdOH whole twice plus 2Ni OH whole twice. So this is for discharging. So can you write for charging? You are going to reverse this equation and you will get the charging reaction. Please write. So today this chapter will be completed. Let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Okay. Now the next cell is fuel cell. It's also a secondary cell, and this is basically fuel cell, also known as H2O2 fuel cell. So I'm going to represent with a small diagram. Please write with me. Let me know after drawing this. So basically this is a compartment in which you can see porous electrode graphite is embedded on the left hand side anode H2, and on the right hand side it is cathode O2, and there is a solution in this chamber of NaOH, that is sodium hydroxide.
Done, sir.
Very good. Now there will be oxidation and reduction at anode and cathode respectively. So at anode, there will be oxidation. You can see 2H2 plus 4OH minus will give 4H2O and it lost 4 electrons. That means there will be oxidation, and at cathode there will be reduction. So reduction is O2 plus 2H2O gains 4 electrons at anode from anode, and it will be converted into 4OH minus. Now net cell reaction, you can see 2H2 plus O2 will give 2H2O plus energy. 2H2O plus energy. This is for discharging also. So you can see on the left hand side there is 2H2O, and on the right hand side there is 4H2O. So this 2H2O will go on the right hand side and subtract, and will get, and will be remaining 2H2O. Now you can see this 4OH minus and OH minus will be cancelled. So this will be left with us. Please write it.
Done, sir.
Very good. Wait a minute. Please wait a minute. I'm going to give you some questions. Okay, let's start. I'm going to share a new page. This is a new screen share. Nadia.
Yes, sir, it is, sir.
Okay, thank you. Now see, please see this question. And some part of the question is on this right hand side. The question is basically we need to calculate the cell potential. The question is basically we need to calculate the cell potential. Can you solve it? Madhya, is my voice lagging?
Yes, sir. So can you show the complete question once?
The complete question is basically the next point is the cell potential is this. We need to calculate
Okay,
the
sir.
cell potential. Yeah.
Okay. So can you scroll it down back to the half cell potentials?
This question. You need to calculate cell potential. And whenever in physics you need to calculate the potential, you just need to add all the potential you got.
Sir, is the answer 1.10?
Yes, it is. How did you solve it? You can see this is oxidation. We need to calculate E cell. That means we need to add oxidation potential
Yes.
plus reduction potential.
Plus reduction
So
potential.
oxidation potential here, its reduction potential is given because you can see Zn plus 2 electron reduction. That's a reduction potential. So oxidation potential of this will be plus 0.76.
Yes.
Yes or no? And you can
Yes.
see Ag2 is a reduction potential. So its reduction potential is given. So we don't need to change the value. So what you did is 0.76 plus 0.34. That will be equal to 1.10 volt. Yes or no?
Yes.
Very good. Okay. Please do this question for. Wait a minute. Question number this. It's almost done. No, not this. 57.
Sir, the answer
Is
is D.
minus delta. So be careful. Can you spot the difference?
Yes, sir.
Yes, what is the difference? What will be its answer? A or D?
Sir, the answer will be D because it's free energy. Delta G, not G naught.
No, the answer will be delta G naught, not
Oh.
delta G. Delta G is basically other than a standard. A standard units delta G naught that defines a standard, and we got temperature value and everything. Then the value will be like this, and we will get minus RTLMG. Should I derive it?
Yes, sir.
Okay, wait a minute. Let me share another page. Can you see a new page? Slide.
Yes, sir.
So see, E cell from Nernst equation, you know that E cell will be equal to E naught cell minus RT NF. Initially, it was ln Q, not K. Okay, ln Q. So you know that at equilibrium, Q and K, you know the difference. You know the difference between Q and K. Yes or no?
Yes, sir.
What is Q? Reaction quotient. Madhya, this Q is basically a reaction quotient. Other than equilibrium, and Kc and Kp is basically at equilibrium. You know what is equilibrium? Rate of
Yes,
forward
sir.
reaction is equal to rate of
Forward
backward
rate
reaction.
is equal. Yes.
That is at equilibrium. So at equilibrium, the value of E cell will be equal to Q. The value of E cell will be equal to 0. Why? Because we had a formula delta G is equal to minus NF E cell. This is the formula we had. So if at equilibrium delta G has a value 0, so E cell will also be equal to 0. Yes or no? Tell me.
Yes, sir.
So E cell is equal to 0. That means E naught, I can write directly. E naught will be equal to RT upon NF ln K, because at equilibrium Q will be converted into K. And we know that delta G naught will be equal to minus NF E naught cell, minus NF E naught cell. So you can see I'm going to put the value. This is E naught. This is also E naught. E naught cell or E naught cell, whatever you want to write, you can write. So it will be almost minus delta G naught upon NF is equal to RT upon NF ln K. So this NF will be cancelled, and delta G naught will be equal to minus RT ln K. So this is the derivation we get. Are you getting my point? You just need to, what you need to do is,
Yes,
from
sir.
this
I got
equation,
it.
you are going to find the value of E naught cell, that will be equal to delta G naught upon NF minus delta G naught upon NF from this equation, and you are going to put the value of E naught cell here, and you will get equation this, and it will be cancelled, and this is the answer. Please let me know when you are done with this. Let me know when you are done with this.
Yes, sir. 1 minute.
Okay. Hmm? Are you done with this?
Yes, sir, I'm done.
Okay. So you can see again a new question number based on this. Wait a minute. This question is okay. This question 56. Very easy question, and it is also based upon ECS, electrochemical series. See the value and let me know the answer.
So is the answer D?
D. Pb plus 2 is a stronger reducing agent than Sn plus 2. No, the answer is not D. For reducing agent, you know that I told you that E naught R value increases, oxidizing power decreases, and reducing power increases, right?
Yes.
Yes or no?
Yes.
So Pb plus 2 is a stronger. No, you are going to see opposite from this. You are going to write the value like this. This will have for reducing agent, for reducing power. That means it will oxidize. Reducing agent means it will reduce someone else before this. Yes or no?
Yes.
Reducing agent. That means it will reduce. It will not reduce itself, but reduce someone else. Like if it is reacting, there is a redox reaction, and if a species is reducing agent, that means it will reduce. It will easily. The one which is getting oxidized is called reducing agent. Yes or no? This is the main term. The one which is
Yes.
getting oxidized is called reducing agent. So you are going to see it from a converse, like Sn plus 2 is converting into Sn plus 4 plus 2 electron. Can I write this? So
Yes.
if this is a reducing potential, so can I write the E naught value minus 0.15? In the
Yes.
same way, if I'm going to write it Hg2 plus 2, it will give 2 Hg plus 2 electron, and it will give 0.92 volt. Again Pb plus 2 plus 2H2O, it will give PbO2 plus 4H plus 2 electron. So before answering lead, you are going to see the oxidation state of each and every element here. So you can see plus 2 here, hydrogen plus 1, oxygen minus 2, Pb plus 4 and oxygen minus 2, hydrogen plus 1 here. And where is oxygen? Minus 2 and 2 electrons here. So it will have a value that is minus 1.45 volt. Now tell me which one is oxidizing and reducing according to this value. We will not talk about lead because lead is reacting in the presence of H plus. In these two reactions, you can see it is easily oxidizing or reducing. It is gaining or reducing, losing, basically gaining electrons without presence of anything.
Yes, it's
and this
gained.
is in presence of H plus. So you are going to compare these two only. So according to these two, the answer will be B or not?
Yes, sir, it will be.
Yes, it will be B. Please watch it carefully and let me know if you still have any doubt. Let me know when you are done with this.
Done, sir.
Okay. Question number 49. Very important question. Are you done with this, Madiha?
Sir, 1 minute.
Okay. Take your time. I'm waiting.
Sir, answer is B, 2.14.
Answer is B. Very good. 2.14 volt. Very good. Okay, question number 47.
Sir, the answer is C.
Answer is, oh, wait a minute. Answer is C. Very good. Question number 53.
So is the answer B?
B is what? ln C2 by C1.
Yes.
Very good. So the answer is, wait a minute. Yes, it is. Very good. Very good. 52 it is. Now, this chapter is completed. Okay. Let me know when you are done with this, or if you have any doubt.
So can you solve it, please?
Question number 52, right?
Yes.
So I'm going to share a new page for solving it. Now you can see. In the question, what we had given is there is a reaction Cu plus 2 and Sn plus 2. Cu plus 2 and Sn plus 2, converting into Sn plus 4 and Cu. Yes or no? This was the reaction. Sn plus. At 25, we need to calculate. We need to calculate E naught cell. A new screen is shared, right?
Yes, sir. I can see.
At 25 degrees centigrade, we need to calculate E naught cell if the equilibrium constant has a value k is equal to 10 raised to the power 6. So this was the value, and we know we have a formula in terms of k equilibrium, and the formula is 2.303 RT upon NF log k equilibrium. This is the formula. Yes or no? You know this formula?
Yes, sir.
So I can also write 0.059 upon n and directly log k equilibrium. So we just need to put the value 0.059 upon n. What is the number of n electron? You can see plus 2 is going into 0 and Sn plus 2 is going into plus 4. That means the number of electron transferred is 2 and log of 10 raised
Yes.
to the power 6. And this will come here and it will be 0.06. Just suppose 0.06. I just round of it and it will be 6 log 10, and log 10 has a value, what is this, 1. So it will be almost, you can multiply it by 0.059 into 3 or 0.06 into 3, you will get 0.18 approximately. Got it? Please write it. Are you done with this?
Yes, sir.
Okay, thank you. So this was very easy question. This question is also very important. Wait a minute, I'm going to give you question number 51. I think you solved it, perhaps. Did you solve this question? Yes or no?
Sir, 51st, no.
Okay, please solve it. Actually, I was about to a test, but I thought it would be better if I'm going to give you some questions, and on this base, I will give you grades. Are you done with this? Can you solve it? Let me know when you are done with this. Nadia, can you solve it or you need any explanation of this?
No, sir, the answer is C, plus 0.382.
Very good. Okay, 44. Can you solve this?
Sir, the answer is C, Fe3 plus.
Very good. It was very easy, right?
Yes.
Very good, very good. You can go for this also. 46.
So the answer is 1.212 volt.
1.212.
212.
It's yeah, B, right? For 46 years,
Yes, sir.
Nadia.
Yes,
In
sir.
the next
It's B.
class, very good. It's right answer. In the next class, we are going to start new chapter, that is haloalkane and haloarenes. Or you want to start any other chapters?
No, sir. It's fine. Not all.
Okay, thank you so much for today. If you still